works out good enough. So a trig equation, simplistically enough, is this. Cosine of an angle is equal to -1/2. We're going to do a little review in chapter 4 while we're doing this one. In chapter, not chapter 4, chapter 2. In chapter 2, we actually did things like this, but it would read more cosine inverse of -1/2 is equal to something. And then we would go through and solve for that cosine inverse. This is not cosine inverse, this is a straight cosine. So the first thing you do when you're solving one of these is you have to recognize what you're really looking at. So how do you draw cosine?
It's going to be in the first and fourth.
What's that?
It's going to be in the first and fourth. But it's negative. So
It's not inverse.
Oh.
We're talking cosine, straight up cosine.
It's the bottom.
What's the highest?
Oh, -1.
Lowest?
-1.
So it goes up 1. It goes down -1. What else? What do I do with the x-axis? How many pieces? 4. So I cut the x-axis into 4 pieces. The first piece is? Pi over 2. Second piece is?
2 pi.
It's not 2 pi.
Oh, pi.
Pi. Next one up is? 3 pi over 2. Where are you looking now? Next one up is? 2 pi. Where's cosine start? High, low, middle.
High.
High. So cosine starts high, then it goes middle, then it goes low, back to middle, and ends up being high. And you get a nice curve that looks like this. And it goes on for in both directions. Remember graphing? In this case, it's actually extremely important to be able to graph it so you can kind of see what's really going on. Where is -1/2? When I say cosine of this angle is equal to -1/2, where is it in this picture? X-axis or y-axis? The y-axis, because you're plugging in something for cosine and spitting out an answer. So if it's on the y-axis, -1/2 is right here. So this is saying, when is the function equal to -1/2? How do I find all the solutions? This comes from a previous math class, dealing with functions. Nothing to do with period. If y is equal to 1/2, I'm looking for x's. So when does that happen? Well, all I have to do is draw a horizontal line. How many times is it going to run into this graph? Just 5?
Infinity.
Infinitely. Because this graph keeps going up and down, and it's going to keep running into it every time it hits a height or a depth, in this case of -1/2. So we're going to have a solution here. If we talk about just the first period, from here to here, it's going to have a solution here. It's going to have a solution there. Someplace between pi over 2 and pi, and someplace between pi and 3 pi over 2. So far, so good? So to answer this question, we have to be really careful. There's 2 main answers. I would consider these 2 the main answers, but there's supplementary answers to the left and to the right that go off to infinity. So we're going to account for the main answers and the infinite answers. And it's really not that bad. Most people kind of get it. So we're going to do another picture. When is the cosine of an angle negative? What quadrants?
The second and third.
Second and third. Second quadrant is pi over 2 to pi. Third quadrant is pi to 3 pi over 2, where those 2 points are. But even without that picture, you should be able to draw a picture. The main one is going to go here. Why am I calling the second quadrant of cosine the main triangle? This goes back to chapter 2. Cosine inverse only works in the first
And the second.
and the second. So the main triangle is going to go in the second quadrant. I call this one the secondary, but I don't draw it as a triangle. I just put an angle line in there. So I'm going to get the answer for the first one and use that answer to generate the second one. Okay. So I drew my triangle in the second quadrant. How do I label the sides? If this is theta, how do I label my sides?
On the adjacent.
Adjacent over hypotenuse, because this is cosine, so it's adjacent over hypotenuse. So where's the -1 go? The bottom. Where's the 2 go? What's the third side? What does that force this angle to be? What?
Is it? No, it's 60.
60 degrees, right? Because it's opposite the biggest side. So this reference angle is pi over 3. So what's that make the first theta? If the reference angle is pi over 3, then how many pieces are to this side?
2 pi over 3.
2 pi over 3. Okay, that gets you to one of the answers. The other one is you have to wrap your angle all the way to here. But the reference angle here is exactly the same. It's pi over 3. So how many pi's over 3 bring you into the third quadrant?
How many pi's over 3 bring you into the third? 4.
4. So theta, the solution to this thing, is either 2 pi over 3 or 4 pi over 3. Now remember, these are considered my main solutions. They're not all of them, they're just the main ones. So far so good? So how do I get to all the other ones?
If you don't put negative infinity to infinity up there.
I am not going to put negative infinity to infinity up there because I want to be really precise. I want these two answers. That's 2 pi over 3 and 4 pi over 3. But I also want these two answers. And I want these two answers going to the left. Forever to the left and forever to the right. But I can't say negative infinity to infinity because that's all the answers. And I just want specific ones. So the question then becomes, if I start at this first solution, how far is it until I get to the second one over there? Or the first one of the second pair? What's this distance, do you think? The curve is going down, it's reaching its bottom and then starting to come back up. The curve is going down, it reaches the bottom and it starts coming back up. How far is that distance? Say it louder. How far? Where it starts repeating itself. It's getting to the bottom of the curve. It's getting to the bottom of the curve. It's getting to the bottom of the curve. What's that called on a cosine function? When I graph it from 0 to 2 pi, and I pick it up and I drop it down.
Translation.
Say the first word.
Period.
Period. What's the period of a cosine function? How far is it from here to here? 2 pi. The period of a cosine function is 2 pi. So if I go from this first answer, which is located on that part of the graph where it's coming down and getting ready to turn, to this one over here, which is coming down and getting ready to turn, that distance has to be 2 pi. Because that's what it means to be a period of a function. If you go to the same location on the curve and it's doing the exact same motion, that distance has to be 2 pi. All right, what's the distance between this point and that point?
2 pi.
2 pi. So the answers are always going to be offset by 2 pi to the left, or, 2 pi to the right, or 2 pi to the
Left.
So I can always go backwards. To get to this one, the distance between these two is 2 pi. The distance between these two is 2 pi. All right, so I can take 2 pi over 3 and add 2 pi to it. That'll give me one more answer. But I can also add 4 pi to it, and that'll give me another answer. And I can add
6.
6 pi to it and get another answer. How many times can I do that?
Infinite.
So what I do is I put k here. And what I do with k is I let k equal dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. What kind of numbers are those? What are they called? No, what kind of numbers are they called? There's no 1.5 or anything like that. So what kind of? They're not whole. Whole is 0 up.
Integers.
Integers. So another way of saying this is k is an integer. K is an integer. So if k is an integer, it could be positive 2k, positive 4k, positive 6k, or negative 2k, negative 4k, and I'm not negative 4k, negative 4 pi, negative 6 pi, and so forth and so on. So this thing right here describes all the infinite solutions starting with 2 pi over 3. So what's the other one going to look like? 4 pi over 3 plus 2 pi k. And this becomes known as the entire solution, the complete solution of this problem. So 2 pi over 3 and 4 pi over 3 are the main solutions, but from them you can get all of them, which is kind of cool if you think about it. And out of all the equations, that's the easiest one in the world. So guess what? It's not on the test. I have to put harder forms on there, you know that. But it all comes from recognizing that solutions are horizontal lines, and they run into the graph infinite number of times. So if I write something silly like sine of x is equal to 2, what can you tell me?
Nothing.
You got to be able to tell me something. What can you tell me? Where's 2 in this picture? It's up 2, right?
Yeah.
And I draw a horizontal line. What's it going to hit? Is it going to touch my graph? If I draw a line way up here, is it ever going to touch my graph?
No.
No. So what solutions am I going to get?
None.
None. The solution is, there is none. Because the graph can't hit 2, because the biggest value sine can get is
Always
1. So that becomes a no solution type equation. All right. Also, if you type it in your calculator, it comes up with a domain error. If you try to. Cosine inverse or sine inverse of 2. All right. So the period of sine and cosine is 2 pi. What's the period of tangent?
Pi over 2.
No.
Pi.
Pi. Half the distance. That's just a little bit of this. Now this will be more like the test. I'll give you an equation that looks like this. Sine of 2x is equal to 1/2. Oh, dang it, I forgot to clear the screen again. Just made a mess. Sine of 2x equals positive 1/2. There, that looks pretty. Not up there on here. So, how do I solve it? Now, I don't need the picture anymore because I know it's going to have infinite solutions that are half high. So then the question becomes, when is sine positive? When is sine positive? What quadrants?
First and second.
First and second. What's the main quadrant?
Fourth.
If you're thinking of inverses, what's the main one?
Second.
No,
Oh,
first and
First and fourth.
First and
Oh,
fourth.
yeah.
So if you're talking about first and second, you're definitely talking first is your main angle. So your secondary angle is going to be in
You confuse me.
sine.
Don't think
Okay,
you're
hold on, ready? Sine inverse works in the first and the fourth.
Mm-hmm.
So I put my main triangle in the first. Sine is positive in the first and
Second.
second. So my secondary angle is going to go in the second. The main triangle is where sine inverse works. I always want you to keep in the back of your mind that sine inverse isn't perfect. But solving the equations, we're doing it perfect. Okay, so how do I label my little triangle? Opposite is 1. Hypotenuse is? The bottom side is? Therefore, this angle is? You knew all the numbers on the triangle. What's the angle?
Isn't it 30?
Oh, did you say 30? I was waiting for pi over 6.
I'm sorry.
I like my radians, you know, pi over 6. So this angle is pi over 6, better known as 30 degrees. All right. So if that's pi over 6, what's this one that opens up into the second quadrant? 5 pi over 6. So my two numbers that I'm going to be working with is pi over 6 and 5 pi over 6. Now be careful. These aren't my answers. Why? What's different between this one and the one I did earlier? Is there any difference between this equation and the one we did earlier?
Yeah, it's a 2 in front of the 8.
Ah, there's a 2 in front of the x. So what I have found is the angle 2x is equal to pi over 6, and the angle 2x is equal to 5 pi over 6. That's great, except for, a couple problems, but I can't do anything yet. So if it's pi over 6, what do I add on to get all the answers?
2 pi k.
So add on 2 pi k to both of them. And this is where people make their mistakes. They jump into solving for x before they put in the 2 pi k. You can't solve for x until you have the 2 pi k involved. All right, so how do you solve for x? Where's my other marker? Who stole it?
What color is it?
Blue.
Isn't it right here?
Am I losing my mind? Oh, it's right here under the paper. So, divide everything by 2. How do you divide a fraction by 2?
Flip it.
So therefore you multiply the... If you divide by 2 and you multiply by the reciprocal, you're multiplying by...
The denominator.
Oh, I swear. If I have 5, and if I have 5 thirds and I divide by 2, that's equal to 5 thirds times...
1/2.
So where does the 2 really end up going?
To the bottom.
To the bottom. Right, that's what I was emphasizing. So you'd multiply this by 2, and you divide this by 2. So taking half of something is the same thing as multiplying the denominator by 2.
Okay.
Alright. And then the same thing here. Divide by 2, multiply him by 2, divide by 2. So therefore, we're going to get x is equal to pi over 12 plus pi k. And then the other one is 5 pi over 12 plus pi k. Infinite solutions. Now let's add on one more layer of difficulty. For the first problem, it didn't actually cause any difficulty. Your main answer are your main answers. The difficulty is this. Some of the questions are worded this way. And it adds on just one more level of difficulty. Solve for all x on the interval 0 to 2 pi. Remember interval notation? Brackets is included, parentheses are not included. So I want all my x's to be between 0 and 2 pi. So to find out which one of these infinite solutions land between 0 and 2 pi, you have to start substituting in for k.
Oh, Jesus.
So you start off with the easiest k. K equals 0. You don't have to go negative because the lowest you can go is 0. If you go negative, you're going to go negative, literally. So 0 is a good place to start. So when k is equal to 0, we get pi over 12 and 5 pi over 12. And they are definitely between 0 and 2 pi. All right, then you increase it. Let k equal 1. So then your answers are going to be pi over 12 plus pi and 5 pi over 12 plus pi. So what does that give you? What's pi over 12 plus pi? 13. Yeah, you're right. 13 pi over 12. And 5 pi over 12 plus pi?
17 pi.
17 pi over 12. Because pi would become 12 pi over 12, and then you just add across. All right, are either of those larger than 2 pi? Mm-mm. When am I going to be bigger than 2 pi with a denominator of 12? Which is 24. So if I get 24 pi over 12, I can stop. Anything bigger than 24, I just have to stop. So k equals 2. So if k equals 2, I'm going to get pi over 12 plus, put some lines in here, plus 2 pi. And we're going to get 5 pi over 12 plus 2 pi. And I just said that we can't go bigger than 2 pi. So here's 2 pi plus a number that's bigger than 2 pi. So the only answers we're going to get for this solution between 0 and 2 pi are these two and these two. That's the final answer. So the solutions that are between 0 and 2 pi are pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. 4 solutions. Kind of cool, huh? I always like this. This is fun. Does it get worse?
Yep.
Heck yeah. What's going to make us have more answers?
Translation.
Mm-mm. What would have to be in front of the x to get more answers?
No.
1 only gives us 2 answers. 2 gives us 4 answers. 3 might give us almost up to 6, but I think some of them only give you 5. So the bigger the number in front of x, the more solutions you're going to find over there. So hopefully I only keep the number below 3.
Below 2. 2
Below 2. It's 2 lousy answers. No fun. Alright. What else can we do with this mess? How about this one? 2 sine squared x minus 3 sine of x plus 1 is equal to 0. Yeah, that's beautiful. The first 2 examples were direct solutions. You know, you go through and you find your angles and you jump into finding your solutions. This one's not so direct. What does it look like? It looks like a quadratic. Now, some people are really good at looking at this and doing what you're supposed to do, but most aren't. So let me give you the trick. This is called quadratic form. And the trick is, let capital A equal the middle variable. What's the middle variable in this case?
Negative 3 sine x.
The variable.
Or negative 3.
That's a coefficient.
Oh, sine x.
Sine x is the variable part. So you're going to let A equal sine of x. If you square it, you know, A squared, what's A squared equal to? Sine squared x. Which happens to be the first variable. So this becomes 2a squared minus 3a plus 1 equals 0. Most people would rather look at it in its form rather than in its original equation. So how do I solve the quadratic equation? FOIL only works if you have a binomial times a binomial. factor it. How do you factor it?
Oh,
To get the middle number and
You can do it that way. Usually these numbers aren't going to be very big, so you could probably do guess and check. I usually don't like guess and check unless the numbers are really small. So you're guaranteed this has to be 2a and this one has to be a, because those products has to be 2a squared.
minus.
So 2a and a. It's going to be minus minus because the last number is positive, because you only have two choices, plus plus or minus minus. The last number is 1, so you only have one choice. 1, 1. If you want to double check yourself, 2a squared minus 2a minus 1a is negative 3a. Negative 1 times negative 1 is 1. So the first one tells you that a is going to equal...
Sin A. Or sin X.
From here.
Oh, 2 sin X.
From here. I'm not even talking about
Oh.
sine. A is going to equal...
Fix it, Jesus.
I get
You
you.
factor, and then you take your factors and set them equal to
0.
0.
Oh.
Because the product of two numbers equaling 0 imply that one of them better be
Oh. A, 1
Then you add
and 1 half.
1 and 1 half. So you get a is equal to 1 and a is... Have we not done quadratic formulas?
Oh yeah, I got that now. I got this right here. I got nothing else.
Quadratics, very
Yeah.
important to be able to solve them. Because they always come back. All right, now you can go and change a into sine and whatnot. There's my other marker. I'm losing markers. What are you doing?
Being nosy.
Yeah. So a is equal to sine of x. So I can say that sine of x is equal to positive 1/2. And sine of x is equal to 1. Because a is equal to 1/2, sine of x has to equal 1/2. Now, the only solutions I want here for the angle on the interval 0 to 2 pi. So we're only going for the main answers. We're not going to need the plus 2 pi k thing.
Fix it, Jesus.
Nah. So how do I solve sine x equals 1/2? What should I do?
Draw a picture.
Draw a picture. So you draw a coordinate system. Where is sine positive? I think we've done this one before. The first and the second. First gets the main one. Second gets the secondary angle. Label your sides. Opposite is 1. Hypotenuse is 2. Third side is square root of 3. Reference angle is
Pi over 6.
pi over 6. Therefore, the other angle is,
5 pi over 6.
so you get x is equal to, so far, pi over 6, 5 pi over 6. First quadrant, second quadrant. One more answer. Not from that picture, but from this one over here.
Oh.
When does sine of x equal 1?
When cosine is 0.
Cosine of 0 is equal to 1.
But
When is sine of x equal to 1?
pi.
No, that would be 0.
Hmm?
What picture do you need to look at?
A unit circle.
So if you're on a unit circle,
Mm-hmm.
which coordinate is sine?
X.
Alphabetical. Y. So where is y equal to 1? Right there at the top. So what's that angle?
Pi over 2.
Pi over 2. So the last answer is pi over 2. And that becomes the solution to that quadratic equation. Kind of cool, huh?
Mm.
Kind of cool. I think. Can I make it worse? Yeah. Unfortunately, the time's up. I only have a few minutes. That's right, I know what's going to happen. We'll come back to this on
Yep.
Monday and do more work on it. Ooh, worksheet sounds good. Cover everything all over again. The worst I could do to you, though the book will get worse than this, is this problem. I probably won't be able to finish it, but I can at least get it set up. Cosine of 2 theta plus 3 equals 5 cosine of theta. What's different about this one than all the others? Has a double angle. So the problem is, if this one was 5 cosine of 2 theta, we would have no problem. We would move it over and go through our solving. But because this one is cosine of a single angle and this is cosine of a double angle, it's a mismatch. It's like having x and y in your same equation and you can't solve. So you either change your x's into y's or your y's into x's. So what's easier, to go from a single angle to a double angle or vice versa?
A double to a single?
Double to a single. So what is the formulas for cosine of 2 theta?
She's still talking. Hold on.
She's learning something right now.
And she's still talking.
Just hang up on her. God. Alright, so what are the identities for cosine of 2 angles?
Oh, gee.
There's 3.
There's 3 of them. So which one do you want to use?
The easiest one?
No, there's a specific one you have to use. I can't use sine squared minus cosine squared. Why? Because this side has cosine. It's not an identity, but you want to try to keep things in term.
What about 2 cosine squared theta minus 1?
That's the one you want to use. Because if you don't use this one, there's no way of getting to the solution, because then you're starting to mix sines and cosines, and you really don't want to do that. So I'm going to rewrite cosine of 2 theta in this format. So this becomes 2 cosine squared theta minus 1 plus 3, put him in parentheses, is equal to 5 cosine of theta. So I rewrite the whole problem so that my angle is now a singular angle rather than a double angle. Alright, now what?
What are we solving for?
Theta.
Oh, okay. Lord have mercy.
When you're solving these equations, you're looking for the angle that actually balances it out.
Can I do something with 3?
Yeah, what do you want to do with the 3?
No, never mind.
Do it, go ahead. You can do it.
No, but... Oh no, because you put it up to the other side.
You could, but there's something else you could do to it. That's just a minus 1.
Oh.
Minus 1 plus 3 is?
Oh.
2. I mean, these parentheses I put just because I'm replacing cosine of theta to theta. But there's nothing holding it in place, so you could just drop them. So then this becomes 2 cosine squared theta plus 2 is equal to 5 cosine of theta. Now what?
If you get them together, you can factor, right?
Huh? What are you thinking? That idea, what is that? Make it look like a
Quadratic.
quadratic. And when you're solving a quadratic equation, you always get it equal to 0. So I need to move the 5 cosine theta. So this becomes 2 cosine squared theta minus 5 cosine theta plus 2 is equal to 0.
Let A equal.
Do the A thing. And I'm not going to write let A equal cosine of theta. I'm just going to write this as 2A squared minus 5A plus 2 equals 0. So wherever you see cosine, you replace it with a big capital A. Great. Maybe we will finish this. We're almost there. All right. How do I factor that?
2A minus 1, A minus 2.
2A, 2A. And you said 2A minus 1 and 2A
Minus 2.
minus 2. Does that work?
We got 4.
4A, 5A, positive 2, and 2A squared. Yeah, that works. All right, so one of your answers is going to be A equals,
Let me have
and A equals,
2
and A was originally what?
cosine.
So this is cosine of theta is equal to 1/2, and cosine of theta is equal to 2. Let's deal with the easier of the two first. Which one's easier?
The 1/2.
Nope.
A 2?
Yep. What's the answer for cosine of theta is equal to 2?
Mm.
Without much thought at all.
It's on a unit, sir?
Nope. I talked about this earlier. Cosine of an angle is equal to 2. What's the largest cosine can be?
Oh, it's a no solution.
It's no solution. This gives you absolutely nothing because cosine of theta can never equal 2. I don't know how many times you know how to say that, but it'll probably be several. But you'll get used to it. How do I solve cosine of theta is equal to a half? So when is cosine positive?
First.
And
Fourth.
fourth. Main one is in
First.
first. So I draw my triangle in the first quadrant, and there is one more in the fourth. All students take calculus. So C is where it's positive. How do I label my sides?
One at the bottom.
One at the bottom. I'll get there. I just want to change colors. One at the bottom,
2 is your hypotenuse.
adjacent over hypotenuse, and then the third side is?
33.
If anything, you learn your perfect triangles nowadays. You know, those pretty pictures, and you won't even have to look at them. Angle is?
Pi over 3. I hope.
It is
Okay.
60 degrees, pi over 3. The other angle is, and you can't go backwards, because my angle is going to be between 0 and 2 pi, so you have to open it up this direction.
Is it 5 pi over 3?
5 pi over 3. So my answers for this problem are pi over 3, 5 pi over 3. Are the only two solutions to that quadratic equation.